Hello everyone, my name is Vanessa and today my topic is mono and multispecies biofilms from a crustose coralline alga induced settlement in the scleractinian coral Leptastrea purpurea. And I know reading the title doesn't mean anything to you, so I made a little character introduction. So the first, our main research subject, the scleractinian coral Leptastrea purpurea, is the orange word here. And it's also my background picture. I hope the color can make you memorize them better. And the crustose coralline alga, and you can abbreviate it as a CCA. Here is a red alga, which is very hot, and it cover on the corals. It's a pink layer, like the background picture. I think it's pretty cute. And the last one is mono and multispecies biofilms. You can imagine it as a layer full of organisms and their self-produced matrix, and including very much bacteria. So now we can understand our title as the bacteria from the biofilms on the crustose coralline alga can induce settlement, which is a step for coral to reproduce in the scleractinian coral Leptastrea purpurea. And as for the coral's importance, I think I don't need to spend too much time on this. So we all know corals are bleaching and dying, and to regenerate them, we need to know how they reproduce. So corals reproducing strategy has two ways. One is spawning and two is brooding. And as for our research subject, is Leptastrea purpurea. He used brooding. So brooding's main difference from spawning is the fertilization's occasion is happen inside their body. It calls internally fertilization. And when they were released, their larvae, which is developed their children, and when they release their larvae, it will settlement, and including attachment to the surface, and they were going through metamorphosis, and then he will become a mature coral. And our main is settlement. And the larvae will first attachment and metamorphosis to complete their settlement. And the previous research have proved that CCA, crustose coralline alga, can induce their settlement too, as their chemical cues. And chemical cues means the signal to the larva. When they receive the chemical cues, they will know it's time to settle. And the other research also proved that microbial biofilm have the same effect, which some bacteria can produce tetrabromopyrrole, which is the chemical here. It can act also as a chemical cue for them to know when to settle. And that is our purpose on this study. In this study, we aim to isolate bacteria from crustose coralline alga and test their ability to induce settlement in coral larvae. To be plain is to know which bacteria in the biofilm from crustose coralline alga can best induce the settlement in coral. And this is our material and methods. We first collected our crustose coralline alga and our coral sample from the luminal. It's located in Grand Island in the Pacific Ocean. And we collected our larvae from our laboratory. And as for the bacteria, we incubated them is to grow them. And first we need to isolate them from the algae, and we need to isolate them into strain. Strain is a special classification for bacteria. They use function instead of characterization, and we need to isolate them into strains and doing the sequencing to know their identity. So And then we made the cover slips, and we made the bacteria on them to grow the monospecific biofilms, and we exposed them to coral lava. And before we enter our results, we need to know what possible responses might lava do. First is swimming, which doesn't do anything, no reaction. And then he will attach to the surface, and then he will metamorphose. And as our target responses is settlement, which include attachment and metamorphosis. So as the result, before the bacteria's part, we use the crustose coral algae to do the positive control at first, and we make sure that the lava's fatality is great, and it resulting 82.6% of settlement rate, while negative controls only resulting 0.6. And our bacteria has 56 strains, belong to 6 classes and 18 families, which most of them belongs to gamma proteobacteria and actinobacteria, then is alpha proteobacteria. And as for the most important result for our settlement rate for each strain, and I tried to find a picture of them, but I think there's no difference between them. So I think just using the color can help you understand. And I use the rainbow color so you can understand. The red is number 1, orange is number 2. And as a result, these 6 strains shows a great result, which they all can induce settlement, but the other strains almost 0. And except for typical result, there are some false responses. There is 0.8% of the lava. They do the attachment to the surface, but they didn't do the metamorphosis. And there's about 3%. They only do the metamorphosis in the water color, but no attachment to the surface. And there is a special case. Some strains cause lava mortality, which means, like this 7084, he caused the 100% death rate for the lava in 48 hours. And what we mentioned before, 1722 and 83, I think is the number 4 and number 6 we mentioned before. They also kill the 20% lava after the 48 hours. So to know more about these two, we do another experiment. We use the multispecies biofilms instead of monospecific biofilms. So first we use the other 4 successful strains, and he successfully increased the settlement rate to 93.2%. Is a great result. But when we mix in the 7022, he successfully decreased the settlement rate to 0 and caused all the lava dead. So as the discussion, in our research, we know that the inductive effects were strain specific rather than linked to higher taxonomic levels, which means that even the same species and genus, but they can have a totally varied result. And for our successful cases, like 1792, we first found that he can induce settlement behavior this great in this research, and he can produce diverse secondary but metabolites, so that may be the reason. And 1678 is known for the induced settlement behavior, but we haven't known what chemical cues he can produce. And as for the 1633 and 1783, we all know he can produce tetrabromopyrrole that we mentioned earlier. He can induce this chemical, can induce settlement. And there are some special cases, like some strains cause larva death instead of settlement, and some strain induce metamorphosis without attachment. Of course, some strain induce attachment without metamorphosis. And 7022 and 7083 is a very special case, and we need to know more about their chemical cue. And as for the best important settlement rate result, we now know that multispecies biofilms can produce a very great settlement rate. Then the crustose coralline algae, then the monospecific biofilms. So we back to our purpose in this study. We now know these four bacteria can successfully induce their settlement, but we not only know these few bacteria can show strong capacity, and we need to know more about the settlement cues may involve, except for this guy. We now only know this guy. So thank you for listening.
I have one point and one question. The first point is that you have so many colors. We lost the number rating ranks in the pyramid, so we don't remember who's the first one, second to the sixth. So maybe change that. And for my question is that after your research, we know that we know some strains of the bacteria can help the coral to settle down, right? So what do you think it is important to our coral restoration? What's the point after knowing this method or knowing this kind of phenomenon?
I think we should improve at knowing what chemical cues the bacteria can produce, and know what chemical cues really can induce the settlement, and then we can know which bacteria is really useful.
Thank you.
I'd like to know why does adding the strain number 72 cause the complete loss of the induction activity?
Well, in that case, we haven't known what chemical cues 7022 can really produce. At first, he really produced a good result. At first, he does have 46.7 settlement rate, but with the time passed, after 72 hours, he started to killing the corals larva, and we haven't known the essential reason.
What does the bacteria number 1722 have a high mortality rate?
You mean why?
Yes.
But we haven't known exactly what chemical cue it can produce, and maybe at first he produced some great chemical, but later he produced some deadly chemical.
Oh, thanks.
So I think you will agree that it's very nicely presented in terms of both, you can stand here closer, in terms of both the PowerPoint itself or also the oral part. So it's a very nice talk, so today's talks are all very nice. And I think I generally have only, it's good, excellent, okay. Maybe I can explain a little bit more about why I feel this talk was excellent. Here at the beginning, she used a skill which some scientists would usually do, which is she used the title of the paper and explain the keywords. So without really going to these specific slides like this, she used the title to explain many things. Then you get a basic idea what the topic is about. So it's a very nice skill that she used. And then later she, instead of say a lot about corals are important, blah, 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 she choose to show you this kind of bleaching. So yes, we should know more about how to restore our coral community, etc. And then she started to find this, is it AI or is it internet? Okay. Okay, so, so she started to find this cute cartoon to explain the phenomena or the process she wanted to talk about. These are all excellent because these are not in the paper, so she really do some job to find some supporting image for her presentation in order for you to understand the topic easily. For example, like a geologist, for me, I found it super easy to follow. This made me very happy because when I was reading the paper, I feel, oh, I really hate this kind of topic. But then she made the story very interesting. That's what I really appreciate. And this is also nicely, there's this one. This one is also a very nice cartoon. And then she later reused this again and again. So you know what kind, you can have a picture image in your mind of what kind of experiment has been done in this study. All right, and this one has been used again and again, and it's very explanatory for her topic. It's nicely chosen. Is it from internet? Yeah. Okay, you see internet has a lot of material you can use. Okay, and then later, because in the paper, the way it presented was, I don't like it, but then she tried to extract the most important number and make it really big so you can know, okay, what's the upper, lower boundary, and then it's really nice you found there sun photos. I appreciate that, although we still don't know what they are. Okay, and she found some photo of the important bacteria, and later for specific species, I know it's difficult. All right, and then it's very creative to use this rainbow color, okay. And then she, for some false response, she came back to this cartoon to explain, and you know, okay, so what was the problem in this false response? So it's all very explanatory. It's an excellent use of all these images available at the internet. Yeah, good. And then, and this was all nicely done. And later, when she tried to explain this simple explanation, she wants to say it's strain specific. It actually means species specific, right? So, and then she remind us again, okay, for or natural organisms, what are the layers they can have in terms of their taxonomy. So it's a nice choice of supporting image. Okay, good. And this is also nice for the discussion. Good. So I think, and then for the for her conclusion, she revisit her purpose. This is also nice. That's something you can learn from her talk. And I think the only comment I have is next time, because at the beginning of your talk you didn't use pointer too often. You use it more often later. Next time try to use it often from the beginning to the end and try to look at them. You can do it. Good. It's a very nice talk, so let's thank Vanessa.